Welcome to the Explainer. So, have you ever stood at the base of a massive skyscraper, looked straight up, and just marveled at the sheer engineering required to keep thousands of tons of steel and glass perfectly upright? Well, today, we're looking at that exact same concept, but in the digital world. We're going to explore the modern skyscrapers of our era, cloud infrastructure. Specifically, we'll be unpacking how to design secure and highly scalable environments using Microsoft Azure.
Now, you might be wondering, and it really is a fascinating question, isn't it? How exactly do your favorite streaming services, or those massive e-commerce platforms, survive millions of users logging on simultaneously for a season finale or a Black Friday sale without instantly crashing? I mean, it's not magic. The answer actually lies in a robust, secure, and incredibly scalable cloud architecture. Microsoft Azure provides the tools and the foundational blueprint to handle exactly this kind of immense, totally unpredictable digital weight.
Okay, let's dive into this blueprint. We're going to build this floor by floor today. First, we'll cover the Microsoft Azure blueprint, then scaling for the masses, fortifying the cloud fortress, continuity and cloud maintenance, and finally, the future of Azure.
All right, moving right into Section 1, the Microsoft Azure blueprint. Think of this as the raw materials, the concrete, the steel girders, and the deep foundation upon which our entire digital building is going to rest. Every sturdy building absolutely relies on its core pillars. And in the Azure ecosystem, the whole shebang rests on three main categories: compute, storage, and networking. These services work in absolute concert. Compute is your raw processing power, right? The engine's doing all the heavy lifting. Storage is the vault for all your vital data. Everything from massive, unstructured files in Blob storage to highly organized SQL databases. And networking? Well, that's the vascular system that securely connects everything, making sure traffic flows exactly where it needs to go, without creating massive traffic jams.
To really get a grip on this foundation, let's look at Azure Virtual Machines, or VMs. Basically, think of VMs as the individual rooms within our skyscraper. They are the fundamental, on-demand building blocks of cloud computing. Instead of buying super expensive physical hardware that just sits in a closet gathering dust, you can deploy these virtual servers effortlessly. It's like turning the lights on when you need a new room, and, crucially, not paying a dime for it the moment you turn them off.
Section 2. Scaling for the masses. Because what happens when our building suddenly needs to accommodate a massive influx of new tenants? This is where the cloud truly shines.
When you hit a growth spurt, you basically have two choices. You can scale vertically, which means pumping more power, like CPU or memory, into your existing server. It's kind of like adding more floors to an already tall tower. Or you can scale horizontally, adding more identical servers to share the load, like building 5 identical towers right next door. And this brilliantly illustrates the crucial difference. Because in modern cloud-native architectures, scaling out horizontally is almost always the star of the show.
Let's actually see this in action. Imagine a massive holiday sale. Boom. Seasonal traffic spikes hit, and millions are logging on. Immediately, the Azure Load Balancer steps up as the ultimate traffic cop, taking the brunt of that massive wave of requests. Recognizing the surge, Azure's auto-scaling automatically spins up more compute resources, and the load balancer perfectly distributes the traffic. No bottlenecks, no crashes. And the best part? The second the sale ends, Azure automatically scales back down, saving you some serious money.
Section 3. Fortifying the cloud fortress. Because, let's face it, a massive, bustling skyscraper is a prime target for bad actors. Time to look at our building's defense systems.
You see, effective networking isn't just about making a connection. It's literally the cornerstone of your security. Tools like virtual networks and subnets let us carefully segment our infrastructure. It's like giving different departments their own completely locked down floors. Meanwhile, network security groups in the Azure firewall act as these strict perimeter checkpoints, rigorously controlling exactly who gets in and who goes out.
So the crucial point is this. In the cloud, you must assume no entities should be trusted by default. Seriously, no one. This is the core philosophy of Zero Trust security. You can no longer just build a really strong perimeter fence and assume everyone inside is friendly. You have to continuously verify every single request as if a hacker is already wandering the halls of the building.
Well, how do we actually enforce that zero trust? Mainly through Azure Active Directory, which is basically the building's ultimate unbribable bouncer. Before anyone even touches a file, they have to prove their identity using multi-factor authentication. And once they're inside, role-based access control ensures they only hold the exact, specific keys needed for their job. It completely minimizes the blast radius. Think about it. If an intern's account gets hacked, the hacker still can't access the executive vault. It tightly locks down your data.
Moving to Section 4,
continuity, and cloud maintenance. Now that our building is perfectly scaled and totally secure, how do we keep the lights on during a disaster? What happens during a digital earthquake?
To survive real-world disruptions, resilience literally has to be built in from the ground up. By using infrastructure as code, with tools like Terraform, for instance, we completely automate our deployments, effectively removing manual human error from the equation. And if a massive storm takes out a data center in one region, no problem. Geo-redundancy means Azure automatically fails over to a completely different global region. Your business never misses a beat.
But hey, we don't just sit around and wait for disasters to happen, right? Azure Monitor and Log Analytics act like thousands of smart sensors embedded right into the walls of our skyscraper. They continuously collect metrics, proactively alerting you to an inefficient resource or a tricky bottleneck long before a single user ever notices a slowdown or starts complaining on social media.
Now, let's be completely clear-eyed here. The cloud is not some magic silver bullet. Running all this infrastructure brings up some very real challenges. We're talking complex cost management, network latency, strict compliance hurdles, and the ever-present danger of misconfigurations. These are the persistent realities of modern digital infrastructure. It absolutely requires careful planning and constant vigilant governance to keep the building standing tall.
Section 5. The future of Azure. Having grounded ourselves in the realities of today, let's turn our gaze forward and look at what's next.
Now, what's really interesting about these evolving trends is the massive shift from us managing the infrastructure to basically letting the cloud manage itself. Take serverless computing. Developers can just execute code without ever thinking about the underlying server, or edge computing, which pushes processing power physically closer to the user, practically eliminating latency altogether. When you combine all that with AI-driven automation, tomorrow's cloud is autonomous, incredibly fast, and exponentially smarter.
Wow, we've covered a lot of ground today, haven't we? From foundational compute all the way through auto-scaling and zero trust right to the edge of tomorrow. Just remember, a robust architecture isn't just about keeping the servers running, it is the absolutely critical driver of innovation for any modern business. So I'll leave you with this provocative thought. As digital transformation accelerates at breakneck speed, how will you architect your secure and scalable future? Thanks for joining me on this explainer, and keep learning.